very systemic implications of a lot of these like pegged assets where they're really deeply integrated into a lot of protocols. And if you have depegs, that can really cause like systemic like negative impacts.
Rob, thanks for joining us today. We did an audit for Cork Protocol a couple weeks ago, and I know you just wrapped up a contest with Cantina, so I'm curious to hear about that's going. But before we get into all of that, I just want to introduce Lisandra and Palina, our rockstar formal verification engineers, and let's break the ice. Let's talk a little bit about ourselves. Rob, how did you get into crypto? What's your story?
Yeah, thanks for having me. It was really great to work with all of you on the formal verification work. My journey into crypto started in 2019. Like initially, it was like I was looking at like Bitcoin, and then I got into sort of the Ethereum rabbit hole. Like this was just before DeFi summer, and then I was just super hooked on that. I'd previously been personally like really into like finance, like options and stocks and all these things. And so when I then kind of discovered kind of DeFi, it sort of aligned very well with sort of my, some of my kind of more libertarian leaning beliefs. And I started, doing a lot of things on chain, and then started contributing to some DAOs. And then I eventually became one of the co-founders of a protocol called Toucan, which is tokenizing carbon credits. And so last cycle we had a bit over 100 million TVL and 4 billion of volume on our carbon credit markets. So that was sort of like we launched that, and it just immediately like exploded and became a really big thing. And so then after that, I just been continuously full time in crypto since then.
It's also super impressive. 100 million TVL. How did you sleep at night knowing that so much money is in your smart contracts? It was definitely stressful, I would say. It was a very crazy period. At that point, we were dealing with kind of real world assets, and so we had kind of upgradability on the contract. So at least like if something did go wrong, which luckily nothing did, we could at least deal with it because it was like a bit more kind of a centralized service. But yeah, it was definitely quite scary, especially like as everything was growing, we just became a very central piece of like a whole ecosystem. We had about 100 projects built on top of us, and there was like all these like massive like media storms going around like this topic, and it was really crazy. No, I'm glad, and I've heard of Toucan, so that's pretty cool. It's a cool protocol. But let's not talk about Toucan too much. Let's talk about Cork. What problem is Cork trying to fix in crypto?
So how I initially got into Cork was I was doing a lot of research on sort of yield rehypothecation and how kind of rehypothecated yields are being like embedded into various protocols. And I think kind of what that research was, like the outcome of that research was basically that you have very systemic implications of a lot of these like pegged assets where they're really deeply integrated into a lot of protocols, and if you have depegs, that can really cause like systemic like negative impacts. And so kind of looking at that, we were kind of looking at how could we solve or like work on that issue, because it seemed like no one was actually working on that problem. And I'd like previously looked a lot at like mortgage-backed securities and credit markets, and so we kind of came like initially with this idea that really these types of pegged assets that are underpinning a lot of these yields, like all this yield rehypothecation ecosystem, is really a form of on-chain credit, and we need to create like markets to price the risk of that credit and create like risk management infrastructure and tooling, similar to something like credit default swap that we have in traditional finance. I do think that Cork is probably the most unique protocol we've audited, or at least that I've been a part of at Runtime that we've audited. So it's really cool to see, I guess, new DeFi pieces coming together. So congrats. When is launch? Well, hopefully it's on Monday, actually. So we're really probably by the time this goes out, this will be past Monday, but so we'll be probably live at the time when this comes out. But yeah, very soon.
Well, I'm glad you took some time to sit down and talk to us, even though you have launch coming up in like 72 hours. I wanted to ask you, so you reached out to us specifically for formal verification. I know you guys also went through some audits, but like as a founder, like what guided your decision to go for formal verification and use formal methods in your security strategy?
So I think we wanted to, like, since this is a new primitive, I think it's especially important that we take security very seriously, especially because we're working with like risk management. So we kind of wanted to do everything like the right way. And so when I was kind of looking at like what's the best way to like guarantee like smart contract security, to me it seemed like if you cover all of the like core bases, you kind of have a like the best sort of shot at there being like nothing wrong. So we did some audits. We did both like a traditional audit with QuantStamp, and then we did some audit competitions, and they kind of there's some overlap there, but they kind of have slightly different angles to them. And I think there's like a trade-off between those two approaches. And then formal verification for us was really, we wanted to make sure that the core primitives, that the economics of them like really worked, and that like all the sort of key properties of the system, we could like really, thoroughly prove that and be really assured that that's kind of true. We think also it's pretty helpful to build out this like formal verification stack to have that as a part of like our testing suite. And so I think that's kind of, one of the other angles is like, I think in a way working through formal verification is, in a sense, it's like an audit because you're really thoroughly going through everything, but then it's also you're building out like all these like internal tooling that you can then kind of keep reusing as you're continuing to develop the protocol, and as we're kind of making changes and so forth. So yeah, that's kind of why we ended up kind of going this route. And yeah, we were looking at like all the different options for how we're going to do formal verification, and we went with Runtime. One of the big areas was, we heard a lot of really good things, but also the like open source like nature. I think that for us was quite important since we kind of want to align with it. Like it's kind of part of our ethos as well.
That's awesome. Yeah, we definitely appreciate that. We're one of the other episodes we were just talking about how difficult it is to fund open source projects. So we definitely appreciate you notice us. And let me ask you another question. When did you first hear about formal methods and formal verification?
I feel like I looked at like a lot of protocols and like what their kind of security was, and like what they've done. I think and some of the protocols that I respect a lot, like Morpho, I think they work with you guys as well. Yeah, there was that. I mean, we were doing quite a big like deep dive into like what's the best way to like ensure security and also be able to like show that externally. And so we were talking to like people, like different people that are kind of very deep into the space, and they were like, okay, if you can spare the budget to do formal verification, you should absolutely do it. So but yeah, I don't know exactly when the first time was that I heard about it, but it was kind of doing that deep dive that I really kind of started to understand it more, like what it meant and what the point of it was.
Okay, so it sounds like once you started researching different security options, it kept coming up. So it's good to know. All right, let's switch it over to our engineers, Palina, Lisandra. How are you guys doing? Lisandra, you're in Portugal, right? And I think Rob, you're also in Portugal. What do you do for fun in Portugal, Lisandra?
Well, yeah. So let me tell you, I have 2 small kids. So this fun part of my life is like in standby for now.
Oh no.
But yeah. But during the summer, I like to go to the beach with the babies, and we also have this house in the countryside of Portugal, and it is like a very quiet and with a lot of nature place, and I really like to go there. And so I have my vegetable garden there. We also have the river, and yeah, so I'm starting this project there to put some horses and cows and yeah, so
I hope you're not going off the grid with your
I
farm.
don't know, in this stage of my life, that's what I most enjoy to do, is like going into this nature place and enjoy being there in this quiet and calm environment.
It's cool. And Rob, what brought you to Portugal?
Yeah, that's a good question.
Yeah, I mean, I came here like around 3 years ago when I initially started working remotely. I was kind of like, why am I in Sweden? Like, if I can be anywhere, then a lot of my family is like not in Sweden anymore. Like my brother's in Australia, my dad's in Germany, and so I was looking at different places to go abroad with like better weather and like better quality of life. And so I was traveling around a bit, and I was traveling a bit in Portugal. I had some friends who were moving to Portugal at the same time, and I just like really enjoyed all the nature here. Like the people are super
I actually
nice.
got one of these.
Amazing. That's so cool. Did you want
Yeah,
to some games? Like
I did. Yeah, there was like a Euro qualifier 2 years ago. So we planned a trip to Portugal, and it just happened to be over St. Anthony's Feast in Lisbon, which I always tell people, I might have shared this before with you guys, like it might have been the craziest party I've ever been a part of. Like the whole city just drinks in the streets. Yeah. I mean, I don't know how else to describe it.
And it's not for one day, it's for like 2-3 weeks. Like it's nuts.
Now, in the north, we have, so there are three popular parties, let's say. So there is the St. Anthony's in Lisbon, and then there is the St. John in Porto and in Rhye as well. And then there is St. Peter in some other city. And so all these cities that have these holidays, so they go crazy with this. Yeah, with this feast.
It was very friendly, and I love the little chocolate shot glasses with like a strawberry liqueur or whatever inside, and you just like throw the whole thing in your mouth. All right, Palina, you're sitting there quietly. You're hoping I'm not going to ask you any questions. Like, you're not going to get away with this.
No, please go ahead. Portugal is amazing, though. I am a big fan too.
Yeah, I'm trying to convince Palina to come and live here.
I can attest to that, and it seems to be working. So I have to fight really hard not to move there yet.
I'll definitely visit Portugal again to see you guys. All right, Palina, let's put you on the spot. 60 seconds or less. What is Kontrol, and how do we use it? Well, you know what? Let's just start with what is Kontrol, because you can't fit much more in 60 seconds.
I don't think I can fit anything in 60 seconds. But so Kontrol is our open source formal verification tool for Ethereum or EVM compatible smart contracts that we develop at Runtime Verification. And it basically gives you all the benefits of a formal verification tool. So it mathematically proves that the code works correctly according to some specification. And it has this integration with Foundry, which means that you can provide the specification in the form of property-based Foundry tests that are written in Solidity. So that is a fairly intuitive way to write them. And if your project already has some property-based tests that you wrote for fuzzing-based Foundry, then you can run Kontrol on top of them to formally verify them and basically get better security guarantees by doing that.
Okay. And why is Kontrol spelled with a K?
We do get this question a lot. It is based on K framework, which is the formal verification, formal reasoning framework that we use in Kontrol. And it supports this K language, which is basically a formal modeling language that we use to define semantics. We briefly touched upon that in the previous episode. But basically what we do, we define semantics of different blockchains, such as EVM or Ethereum Virtual Machine in this K language. And defining semantics basically just means assigning meaning to the instructions of EVM in K. So it's like some sort of modeling or a translation between EVM instructions and this K language that we can reason about mathematically. And the benefit of doing that is that we can use the same tool set for formally verifying things for different blockchains, languages, and things like this. So we do have pretty much the same backend or like verifier for Ethereum, for Rust, and well, a few other languages and systems, just by defining all these different semantics. And another benefit of Kontrol relying on Ethereum semantics that we have defined in key is that that is a complete semantics of EVM, and we know that it works correctly according to how a normal or like a client EVM would, because we are running tests from Ethereum Foundation on our EVM semantics to make sure it actually does behave as it's supposed to. And that also enables us to run verification on the bytecode itself. So even though the input to Kontrol is Solidity smart contracts, we do analyze them on the EVM bytecode level, which means that we don't have to make any assumptions about whether compiler behaves correctly or whether there are no bugs in the compiler, because whatever is getting verified is the code that is going to be deployed on the blockchain. And if there are any issues in the compiler, then we probably are going to identify them.
That's awesome. And how does it compare with other formal verification tools? Are they all using EVM bytecode, or is that something that's unique to Kontrol?
Some of them do, and some of them work on Solidity or another intermediate representation that is somewhere in the middle between the smart contract and the bytecode.
So what's the benefit of... I was just going to say, what's the benefit of running it on the bytecode?
So the primary benefit of running it on the bytecode is, there are two. So first of all, you don't have to make assumptions about the compiler working correctly. So whatever you analyze is the same thing that will be running on the blockchain, provided that it's going to be compiled with the same compiler version. And the other is that you don't have to make adjustments because of the changes in the compiler. Like language itself and Solidity specifically does change quite often. Semantics changes, syntax changes quite a lot. And you have to, if you are analyzing Solidity, then you have to basically keep track of all of these changes, and you have to make changes in the tool. EVM bytecode changes way less frequently. We still have to do some maintenance work, which is also what we are doing now for Pectra. But that happens way less frequently than the changes in the Solidity compiler. The downside of using bytecode is that it's just a bit more complicated for us, because during the compilation process, a lot of high-level or like structural information gets lost. So if you are analyzing high-level Solidity, then you can see just visually where the loops are, function entries, and other things like this. That makes the analysis easier. In bytecode, we have to infer that using heuristics, for example, for loop iterations. One of the problems with formal verification, one of the challenges in formal verification, is that it's hard to verify loops, because if the number of iterations is not concrete, then you can run into an infinite loop and you have to bound them. But to bound loops, you have to be able to identify loop iterations in the first place, and then just stop at an iteration number n, depending on what you want the depths, like the max depth, to be. So yeah, I guess that is a challenge, probably more than you wanted to know, Paul. Sorry about that.
No, that's okay. That's okay. It's all helpful. And we talked a lot about Kontrol in the last video as well. So I wanted to invite Rob and get more practical to actually take a look at some of the work we've done, walk people through it, show them how to reproduce it, get people more excited about using Kontrol. So Lisandra, do you want to pick like one proof we did for Cork that was maybe your favorite or most impactful? And like, let's talk about it a little bit. Like, what did you set out to test?
Yeah, sure. So first, let me give some introduction. So when we formal verify a protocol, we are looking to verify correctness properties about the protocol. And these correctness properties can be safety properties or liveness properties. So the safety properties usually want to guarantee that nothing bad will ever happen. And the liveness properties want to guarantee that something good will eventually happen. So for instance, a protocol that doesn't do anything is safe, of course. So beside the safety properties, we also want to guarantee that the protocol is doing what it intends to do. Okay, that said, let me share screen. Let's pick some proof. Okay, so first, we have the setup function into there. So we have the setup function, which basically deploys the necessary contracts to prove the properties. And what's the difference between this setup and a usual setup for a Foundry test suite? So in this setup, for instance, this test module core contract inherits from module core, but in its constructor, we are using this KVM cheat code symbolic storage, which basically puts the storage of this contract all symbolic. And this is very important because it means that we are not proving the properties for a single initial state, as it happens in Foundry tests, but we are proving the properties for the most possible arbitrary state. And okay, after doing this setup, we also have to identify which invariants we want to prove. I mean, what are the safety properties that we want to ensure that the protocol preserves? And after discussing this with the Cork team, we identified the key invariant of the protocol. And this invariant is that each DS and CT are always backed by PA or RA. In the sense that
just for context, like what do those acronyms stand for context? If somebody is not that familiar with the nitty-gritty of the code.
Mm-hmm. Mm-hmm. So when a user deposits RA into which is the redemption asset into the protocol will mint DS and CT to this user, and then the user can use either DS or CT to redeem again or to withdraw again the redemption asset. So in other protocols, so if a DPEG swap events, so the user is not protected against losing some assets. And so the innovation of Cork is that it wants to protect the user against these DPEG swap events. And so the main invariant that we want to prove is that DS and CT are always backed by PA or RA, in the sense that even if a DPEG swap events, then the user will always be able to get back again is RA or PA.
Right. There should never be a state where there's more DS and CTs than there are PAs, right? That's basically
exactly
what it is.
Exactly.
Cool.
Mm-hmm. Yeah. So this is a safety property in that sense that these bad things should never happen in any state. Okay, and that's this is how we translated that invariant into solidity. So the total supply of DS should always be equal to the total supply of CT, and also the total supply of DS should always be equal to the balance of PA plus the balance of RA of the module core. Okay, and then let's see how do we actually prove that this invariant holds for a specific function call. So here we have the test deposit PSM correctness, in which we will prove the correctness of the function deposit PSM. To start, we need to make some assumptions about the initial state. For instance, we need to assume that the PSM is not paused or the DS is not expired. Otherwise, the call to this function will revert. So we want to make the necessary assumptions so this function can go through without reverting for any other reasons. Okay, so we make the necessary assumptions and then we take a snapshot of the state of the protocol before the function call. So we basically store some information about the state variables or about the balances of the accounts involved in this transaction. So before calling the function. And then we will assume that this invariant holds before the function call. So before calling this function, each CT and DS are always backed by PA and RA. And then we will call the function and note that with control, this is not a concrete amount. as it is in Foundry. In Kontrol, this amount is symbolic. So it can have any value between 0 and this ETH upper bound that we defined for simplicity, but it has like a wide range of possible values. Okay, and so after calling the function and after the function finishes its execution, we want to assert that this invariant is still holding, which means that the call to this function with this symbolic value didn't break the security guarantee that we want to prove. And we also take a snapshot after the execution of the function, and then we want to assert that actually the state of the protocol changed as expected. So we want to prove that the function did and executed as expected by analyzing the new values of the state variables and the new values of the balances. So we assert that the state changed as expected. And so this is just one example of proving the correctness to the deposit PSM, but the structure to prove the same invariants for other functions is the same. So I can quickly show, for instance, for the liquidity vault, but it's basically the same structure. So we take a snapshot, we make the necessary assumptions, we assume that the invariant holds before the function call, we call the function, we assert that invariant holds after the function call, we take another snapshot, and then we assert that the state changed as expected. And so that was our approach to prove all functions in this engagement.
All of these proofs are written in Solidity. It looks very similar to Foundry tests. What is the kind of the delta in difficulty between, if you're really good at writing Foundry tests, how difficult is it to take the next step and write control tests and formally verify those properties?
Is it for me?
Hey, whoever wants to answer, Rob, I mean, if you have any input, please.
Yeah. Well, I think that the delta is very small. I mean, if you have a Foundry test suite, we can always try to run it with Kontrol. And the difference is that instead of having these function parameters or these test parameters as concrete arguments, even if you fuzz them, they will always be concrete up to the, 256 possible values, but they are still concrete values. And with Kontrol, these function parameters are symbolic. So you will prove that the test passes not only for these concrete values, but for every possible value that this argument can take. And so I think that with very small effort, you can extensively increase the coverage of your test suite. So I'm a big fan of Kontrol.
Yeah, it's good. And how difficult is it to run the proofs? Because we kind of saw the code, but how do you actually execute them?
Yeah, so for this engagement, we have like a control.2ml file in which we specify like some flags or some, how can I say? Palina, can you help me? But
is it options? Settings?
Yeah, exactly, that's the word. So we specify the options to build with Kontrol and to the control proof command. And then we can just like type in your CLI control build and control proof. And that's it.
Okay, so let's zoom out a little bit and let's bring it back to Cork. Rob didn't just join us today to listen to us, plug Kontrol all over the internet. So I think when I first learned about Cork Protocol, I think we talked a lot about like backstopping stablecoins, right, from depegging. And obviously the event that came to my mind was the USD Luna crash, which was like back when I was very much much more of a degen than I am now, I guess. So I had a lot of money in Anchor, and like that was like a very stressful event. But like in a case of extreme market event like that, like how would Cork help protect investors, and would it hold up? Like, what do you think, Rob?
Yeah, I think in terms of the protocol holding up, I mean, as we kind of saw in the proofs, I think the system is like we can like formally prove that it is fully collateralized, so the system should like work as intended in all scenarios, including Black Swan event. I think kind of the impact or like how this would like what would happen in the scenario with UST is, I think before the DPEG itself, you would have had like a risk price for UST. I think this could have been an important like information signal. If you saw a very high risk price, it might have dissuaded some people from actually investing in UST. And the reason why this risk price would be high is because there was a lot of people that were very outspoken about that this was going to like crash and fail. And so this would have given them an instrument where they could actually bet on that and had a massive significant like financial upside if they were proven right. So therefore, like presumably a lot of people would take that bet, and therefore the risk price would be high, which gives a signal to the rest of the market that like clearly like people, you know, they're not just like fudding UST, they're like, you know, think that this is something that's not going to work out. In the actual event of the DPEG, people who held the DPEG swap and were hedged, I mean, they would have covered their loss. So like, you know, if you would have been farming anchorage, but you would have hedged your exposure, then, you know, even if it would kind of crash, you would still be fine. But then on the other side, the people who are underwriting the risk, the people who think that anchorage was not, you know, or like UST was not going to collapse, they would instead be stuck holding the bag. So that's kind of like the two sides. But you basically, you would be able to exchange the risk, and I think that, you know, would have probably like there's probably certain actors that got hurt in this event that maybe could have hedged their exposure. I mean, for example, like 3 Hours Capital, like a big reason they kind of blew up was because they had such high exposure to UST, and because they had this exposure, and when that collapsed, they kind of defaulted on their obligations towards other parties, and then that resulted in this like cascade of bankruptcies where like Celsius and BlockFi and eventually like FTX like all kind of collapsed because 3 Hours Capital couldn't like pay back the debts there. So I think in a sense you could imagine if those actors that are taking that exposure would have hedged their exposures and like managed the risk a bit better, potentially wouldn't have had such a big kind of ecosystem impact across the board. So that's kind of hopefully the impact that would have had in that scenario.
Yeah, so that's cool. So it's as DeFi is maturing, we need more and more protocols like this. And then one other thought as you were talking that came to my mind was, I guess if somebody's underwriting, for example, something like USD that was maybe considered a high-risk stablecoin, they could also take a short position on it, right, and collect the yield from Cork Protocol, but at the same time hedge even further, right? So it's just kind of like many layers to think about. All right, so let's start wrapping up. We're almost at time. Palina, what's one takeaway you'd want every kind of Web3 developer to get out of this video?
Right. Well, I would say that it's probably that in addition to the high level of security assurance that you're getting from formal verification, and as a very important byproduct that you are receiving, it's this like specification-based mindset that you acquire in the process of doing formal verification that also helps guide further development processes.
Right. And I mean, in reality, you don't even have to be a developer to think about what should always be true about your protocol, right? Like, I think the example I often use is just like, if you look at Aave, there should never be more debt than deposits, right? Like, the Aave should never reach that state. So like, that's something that, again, you literally don't have to be a developer to like think of some of these properties about a protocol. So even if you're a non-technical founder, like you could, if you understand what your protocol is supposed to do, you should be able to like design some of these properties and help guide the formal verification process. I think that's kind of what you were saying, right? I don't know if I'm interpreting everything correctly, but
Yeah, exactly.
Cool. And then, Rob, I know like you guys went through, I think, multiple audits. You did formal verification with us. You went through a competition or maybe even 2 competitions. I'm not sure. I'd love to hear more about like the overall process. Like what would you do differently, or like what advice would you give to other founders when they're trying to launch a protocol and they're considering all these different options that are available to them? Yeah, like I want to hear your thoughts.
I think that the timing of everything, I would have, the one thing I would have probably done differently this time would probably be to make sure that like we're really at like a frozen state of the code when we kind of go into all the audits and especially like formal verification. I think that was one of the challenges we had in terms of like we had a lot of moving pieces throughout, and I think that kind of created some additional complications. And it was because we were kind of aggressively pushing for a certain timeline, and eventually those changes kind of made it so we had to kind of delay things a bit further. But yeah, it would have been more time efficient to kind of have everything like fully solidified and then run through the whole security process. But in general, I think I would probably do most of it similar otherwise in terms of like scope. I think running through formal verification plus like multiple audits, especially those multiple audits, like ideally being one competition based and one non-competition based. I think that to me feels like the best practice in terms of covering all the bases. So I'd probably do that again. And yeah, I think in particular when picking like auditors and picking like service providers, I think it like brands are important, but ultimately it's like who you actually work with on the day-to-day that really will probably guide like quality of that audit work. And so I think having specific good auditors in the auditing firms do your reviews. I think that would be something I would prioritize or continue prioritizing.
Yeah, that makes a lot of sense. I do think there's like different advantages and disadvantages to using contests versus audits versus formal verification. So having a little bit of everything, I think gives you a nice assurance, as nice as it can get. All right, that's all the questions I had. Except I always love to add more music to my Spotify playlist, and I like all sorts of different genres. So, what are you guys listening to these days? Share a song.
Well, it's hard to pick just one song, right? But well, that's for me. So I've been listening a lot of Cheeky Tunes and Panda songs, and these songs for children. So
wheels on the bus go round and round.
Every day. No, but actually, so my babies have this very cool thing because sometimes they ask me for shaking head songs, and so their favorite songs are one cover which is half fado and half heavy metal, and is one cover of All Together Now from Beatles. I will send you the link after the meeting. And then they also like Smells Like Teen Spirit from Nirvana. And so they really like these songs and shaking their head. But yeah, one cool song that I discovered recently is Voila from Barbara Pravi. So she is French, and it is different from everything I have in my Spotify.
Hey, no wrong answers. My taste is all over the place. So.
And fado. Well, I'm not a Portuguese person if I don't recommend you fado, right? Amalia, maybe.
I was listening to fado today, the whole day after Lisandra sent it to me. So maybe I will make it my genre of the week too.
I'm into it. Rob, what about you?
Well, we're in a sort of launch prep mode, so it's more like techno. If you're really into sort of psychedelic techno, I would recommend Acid Poly. Specifically, he has like some really good sets. Like he has some Burning Man sets that are really good.
I think I only know of Infected Mushroom because I ended up at a concert by accident once. But I was always into trance, so like that was just like a little bit different than what I was used to, but I was into it. I've been listening to Enter the Wu-Tang, the 36 Chambers, because I just discovered they apparently released a show that was nominated for all these awards that I didn't know about. And from when I was like 13 to 16, I lived in Staten Island, basically right in between those two neighborhoods, which like it's kind of funny, but so it's just like all the in the TV show, like all the sets, all the recordings, like all the streets, like all the train stations, like I definitely been to, so it's very nostalgic, I guess. And I've just always been a big fan of the Wu-Tang because of the Staten Island connection. So it's a little more ratchet than the other options, but all right. Thank you guys. I really appreciate you doing this with me. Thanks, guys.
Thank you. And Rob, if you ever want to visit Braga, please
yeah.
Palina most certainly will come here in summer, so July maybe. So if you want to wait until there, you can come and visit as well.
Yeah. Sorry. Thank you so much.
And I'm not invited, right?
No.
Yeah.
This podcast is for informational purposes only. Views expressed are solely our opinions, not financial advice. Participants may have investments in the projects discussed.